In this question, we are going to find the area in the first quadrant include between the parabola y square equal to bx and the circle x square plus y square equal to 2bx. So we have the circle and the parabola. So first of all, let us find the point of intersection of these two curves. So we are taking the circle. So first of all, we have to find the center of the circle. So how to find the center of the circle? So we have this general formula of the circle. So x square plus y square plus 2gx plus 2fy plus c equal to 0. So center is given by minus g minus f, and radius is equal to square root of g square plus f square minus c. Now when you look in this equation, if you compare this equation with this, if you compare this equation, if we compare this x square plus y square minus 2x equal to 0 with this standard equation here, with this equation, so here g is minus b and f is 0, c is also 0. So if we put here, center will be minus of minus b, and here this is 0. In the same way, radius will be minus b whole thing square plus 0 square minus 0. So this is nothing but we get here b square, which is equal to b, and this center we get as b comma 0. So center of the circle is b comma 0 and radius is b. So here we get is a circle with center b comma 0 and radius equal to b. Now this is a parabola. Okay, this is a parabola at the vertex y square equal to bx is nothing but it is a parabola. Now we'll try to find what will be the point of intersection of these two curves. So we have taken the curve x square plus y square minus 2bx equal to 0. Now y square equal to bx, another curve is parabola curve is y square equal to bx. So in place of this y square, I'll put as bx. So we get here x square plus bx minus 2bx equal to 0 using star. Then you take common x, so we get here x plus b minus 2b. So you can minus this 2, so we get minus b. So x minus b, so we get x equal to 0 or x minus b equal to 0. That means x equal to b. So we get 2 points, x equal to 0 or x equal to b. Now when x is 0, we have to find what is y. Okay, so when x is 0, you put here, you put in this equation. When x is 0, y is also 0. When x is b, we get b squared, so square root of b squared is b. So when x is b, y is b. So we get these 2 points. So we get the point of intersection to be 0, 0 and b comma b in the first quadrant. Now if we take this, if we have this, see, so this point is, we try to draw a circle with center at 0, 0. So I'm taking, first of all, I'll draw here, I'll show you this. So this is y-axis, this is your x-axis, so b comma 0 will be somewhere here. So this is b comma 0 and this distance is b, radius of the circle. So this will be nothing but it will be 2b comma 0, and this, okay, so we'll try to draw a circle with center at b comma 0 and radius b. So this is your circle with center 0 and radius b comma 0, and we have a parabola, and this is your point b comma b, because radius is b. So this also, this coordinate will be, here will be, this point will be nothing but b comma minus b. Now you draw a parabola. So parabola show the point of intersection is at 0, 0 and b comma b in the first quadrant. If you take in the negative side, it will be, the point of intersection will be also b minus b also. So we'll try to draw this. So we have this is your curve, so this is your parabola. In this way you can draw the parabola. So this is the parabola y square equal to bx, and this is the circle x square plus y square equal to 2bx. So we have to find the area bounded in between these two regions. So this is your area. Okay, so I'll drop this perpendicular here. So this I'm taking as a, b, I think I have taken in the same way as, sorry, a, e, and here I took b. So here I can show from here already I've done. So a, e, b, and here I take D down, and this point I'm taking as C. So coordinate of C is B comma 0. Now required area, I'll take first the whole area, this part. I'll take this whole region. Okay, I'm taking this whole region, and I'll subtract with this small region. So if I subtract with this region, I get nothing but this region. So I'm taking area of AEBCA, means this region full, big, this region full, then minus with this region. So ADBCE, ADBCA. I'm taking the area of this, so ADBCA. Now we'll try to integrate. So we'll just give integral symbol first. So integration y dx minus integration y dx. So how to find the limits? So what is the point on this x-axis, ranging from on the x-axis? So the x range coordinate here, x is 0, here it is b. So the limit will be 0 to b. So we have 0 to b for both 0 to b. Now when I take this area, which curve is involved? The curve which is involved here is the circle. So we had to find the value of y from the equation of the circle. So we are trying to find the value of y from this equation. So that is nothing but y equal to square root of 2bx minus x squared. So we get here y equal to 2bx minus x squared dx. And minus, when I take this area, which curve is involved? The curve which is involved here is the parabola. So we'll try to find the value of y from the parabola equation. So that's why y is equal to square root of bx. So we get here square root of bx here. So we get here y equal to square root of bx dx. Now we have to integrate this. So this can be written as square root of b into square root of x. Square root of b is constant, will come out of integration. Now this we have to complete the square. So we have taken 2bx minus x squared. You can take minus common. So we get x squared minus 2bx. Now minus, so x squared, I'll try to split in the form of a minus b whole thing squared. So a squared minus 2ab. So this is your b, so b plus b squared. So this is not there here. So I have added by itself, so I have to subtract. So I have subtracting here. So this part, okay, this part is nothing but x minus b whole thing square. So we get here x minus b whole thing square minus b square. You multiply this minus inside, so we get b square minus x minus b whole thing square. Now in place of 2bx minus x square, I can write this. So we have this b square minus x minus b whole thing square dx. So I'll integrate this root x. So root x is x half plus 1 divided by half plus 1. The limit is from 0 to b. So this we have to use a standard integration formula, that is x by 2. Here x is x minus b. So x minus b by 2 square root of b square minus x square, x minus b whole thing square, plus b square by 2. So we get b square by 2 sine inverse x minus b by b. The limit is from 0 to b, minus 2 by 3 here, because from here we get 3 by 2. If we go up, we'll get 2 by 3. So x 3 by 2 from 0 to b. So we're getting 0 to b here. So b minus b, we get, we try to put the upper limit here. So in place of x, we put the upper limit first, then give minus sign, then put the lower limit. So in place of x, I'm putting 0. So here b minus b, this whole thing will be 0, so it will not contribute anything. This also b minus b, we get 0, so this also will be 0. So here also b square minus b square, this also will be 0. Only we are left with this and this. So we get here minus b by b, so that is nothing but minus 1. And here we get b3 by 2. So we get here minus 1, b3 by 2. b3 by 2 can be written as b into root b. So I'm writing in place of b3 by 2, I'm writing as b into root b. So this root b into root b, we get b. So b into b, we get b square. So we get 2 by 3 b square. So in place of minus 1, I can write sine minus pi by 2, because the range of this sine inverse is from minus pi by 2 to pi by 2. So we have here sine minus pi by 2. So sine and sine inverse get cancelled. So we get minus pi by 2 minus 2 by 3 b square. So minus into minus, we get plus. So we get here pi b square. Pi by 2 into 2, we get 4. So pi by 4 b square minus 2 by 3 b square. So I can take b square common. So if I take b square common, I get here pi by 4 minus 2 by 3 square units. Thank you.